Hey everyone, it's a new unit in pre-calculus. Go crazy, blah, go stupid. Blah. We're on unit 7, and that means it's time to enter the matrix, which we will not use to make a matrix joke about.
I'm trying to tell you that when you're ready, you won't have to.
There are a number of uses for matrices, but a lot of these are used for like advanced techniques that you wouldn't really encounter unless you went into, like a specific college field for them. We'll get into that a little later in the video, but what are we going to be using the matrices for? Since our options are kind of limited, this will be a shorter unit that is mainly based around using them for systems of equations. To refresh your memory, a system of equations is a set of equations that can interact with each other through algebra. These equations have solution sets, meaning that there is at least 2 answers for every problem. The solutions to a system are based off of the points of intersections for the 2 functions on a graph. Linear lines will only intersect at one point, meaning the solution set for their system would be a single x and a single y value, which make up the coordinate of the intersection. Algebraically, this means that plugging either the x or y value you found into both equations will produce the exact same value for the other variable. It's possible for different types of graphs to intersect more than once, meaning that depending on the equations there may be more than one solution set, and you'd be required to find all of them. We'll also be expanding the concept to 3 equations with 3 variables and seeing if we can solve for a solution set with 3 values in it. This eventually leads to the idea of working with a matrix, but the important groundwork for this unit is laid by systems of equations. Once we're comfortable with complex systems of equations, we'll transfer that idea into matrices and spend a few lessons understanding how to work with them. While most of the math in this unit is just simple like adding and subtracting and multiplying and not really dividing, but maybe some. Systems and matrices can have a lot of steps to them, so be ready for problems that are easy but are also kind of pretty time consuming to do. The kind of problems that make you ask, why do we need this? Well, let's look at the footage and find out so that you don't have to be upset. Video game graphics have been using matrices since their creation, with the original Nintendo Game Boy as a fantastic example, as it uses a dot matrix screen, which essentially assigns each pixel a number value which affects its brightness. When put together, they form the monochrome green images on the Game Boy's fuzzy screen. When the Game Boy Color came along, this matrix became more complicated, assigning brightness values to every color in the Game Boy's color palette to make full color images. With more advanced graphics, matrices can do even more complex tasks, such as using a matrix with negative values to reflect an image across water or a mirror. In physics, matrices are used in the study of electrical circuits, quantum mechanics, and optics. Engineers use matrices to model physical systems and perform accurate calculations needed for complex mechanics to work. Electronic networks, airplane and spacecraft, and chemical engineering all require perfectly calibrated computations, which are obtained from matrix transformations. In hospitals, medical imaging, CAT scans, and MRIs use matrices to operate. In programming, matrices and inverse matrices are used for coding and encrypting messages. In robotics and automation, matrices are used to set up movement. Many IT companies also use matrices as data structures to track user information, perform search queries, and manage databases. In geology, matrices are used for making seismic surveys. Matrices are also used in representing the real-world data, optimization, and economics, and basically anywhere else where it's convenient to have arranged data and information, especially when putting it into computers. These are just a few examples of what matrices are capable of. What we're doing doesn't really necessarily apply to these things exactly, because a lot of the matrices mentioned in those things are like far more complex. But as always, this class is supposed to be like a launch point for math that may lead to those kind of things, to spark your interest or understanding what you're getting into for all the math and science STEM field things. So thanks for watching, and I'll see you soon. It's gonna be fun.